Hi everyone. My name is Doug Wade. I work at Indeed. I'm a senior front-end engineer here working on our front-end team, and I help people get jobs. I'm a maintainer on Lerna and React Server, and I wanted to talk to you a little bit today about React Server. I especially want to say thanks to Nav for inviting me. It's kind of strange because Nav is one of the original authors of the React Server project and was instrumental in getting it started, and I just got a chance to sort of carry the torch afterwards. I really wish I could be there with you in San Diego. It's going to snow here in Seattle starting tomorrow, so let me tell you, I wish I was there with you instead. So React Server. What are we trying to solve with React Server? There's a number of things that we were thinking about when we started working on the React Server project. And one of the big ones is JavaScript fatigue. We had a large group of younger engineers, primarily engineers who have been working in Java code bases, and the universe of JavaScript tools out there is just bewildering. It's enormous, and it changes really often. And so we couldn't expose an API to our clients that would require them to use a bundler directly, or maybe something like Browserify or Webpack. We couldn't expose, all of these different tools to them. We had to instead make it more accessible to them, make it something that was less complicated to set up and something that's more accessible to Joe or Jane developer. And it took us a really long time to get this all set up. Even for really experienced devs who've been working in this environment for a long time, it was a long time to get a good Webpack config and a good Babel setup and a good server-side rendering story set up behind it. Another thing that we were thinking about a lot was slow internet. This graph here comes from the International Telecommunication Union, which is part of the UN. And really what that's trying to show you is the difference between people who are on fixed broadband subscriptions, people who are on desktop on the bottom, and people who are on mobile on top. And what you should notice here is that the mobile bars are a lot bigger than the broadband bars. It turns out that most people on that are trying to access websites in this world aren't people who are in the office wired into an Ethernet connection on their desktop. They're people who are in the developing world on their phone who are trying to access your content. And they just don't have the patience to wait for 4 megabytes of JavaScript to download and then be parsed. They want to get the content in 2 seconds or less. About 47% of users said that they expected their page to load in 2 seconds or less. So we wanted to come up with a solution that would work really well for those mobile users who are loading up the page for the first time. And the other thing that we thought about was people who are without JavaScript. I know that it's not really very common anymore to be a user who runs without JavaScript. It's kind of people who are really worried about security, or it's people who are really worried about advertising. But there is one other user that doesn't use JavaScript that we thought about a lot, and that is SEO crawlers like the Google bot or the Bing bot. Although the Google bot does have some capacity to use JavaScript when it's doing its SEO crawling, it doesn't seem that any of the other bots do. And it seems that the JavaScript-enabled Google crawler crawls less often and for a fairly short amount of time. So we needed to have something that would allow us to be indexed by the Google bot and by the Bing bot. And the answer to this question for us was really this idea of a combination of the server-side rendering with this more SPA-style thing. For the user who's on mobile, what they want to do is they want to get a server-side rendered initial page that loads really fast and then just comes immediately as an HTML document and works. And then for the subsequent loads, they want only incremental data, only the data that they need to render the next page. And so what we wanted to do is we wanted to set up this hybrid model, this half server-side rendered, half SPA. And this also works really well for bots. The bot doesn't ever get all of the JavaScript. It just gets the HTML and it parses it. It's been fully rendered and it works for us. And it allows us to get really great performance because you can load the rest of the data in the background. When we started out, there weren't a lot of solutions, but I do want to stop for a moment and mention that we're not the only game in town. I want to call out in particular Zeit.co's Next.js, which is by Guillermo Rauch and the rest of the guys over at Zeit, and is absolutely incredible. And also the Electrode project that's being worked on by Alexei Grigorin and the guys at Walmart Labs who did Happy. The three solutions are fairly similar. They all have a great Babel setup and a Webpack setup and Redux support, hot module reloading, and sort of all of the things that you would want to have a great server-side rendered stack. There are some minor differences. For instance, Electrode does a better job of supporting Happy and Koa than either Next or React Server does. They also use the React router stuff. Next has a really simple routing API that's based on the file system. But I just sort of, at the outset, wanted to call out that there may be other solutions out there that might be better for your particular use case. Of course, my favorite solution, though, is React Server. React Server is, at its very core, just an express middleware that brings to the table a lot of the functionality that you need to do server-side rendering, and then the accompanying middleware stack in the client to mimic that while you're in the browser. It also includes an associated build tool chain that's based on Webpack, and a constellation of other modules that are built with Lerna to keep it together. And it just works out of the box for beginners, but it has space for you to customize with custom Webpack loaders and plugins and custom Express middleware if you're an advanced user who has better or more complicated needs. The features that I really think set us out from the pack are these. The most important one to me is this buttery smooth page load. One of the dark patterns on the internet that I think is the most insidious and perfidious is when you go to click on a link and then an asynchronous button loads over the top of it and you click on the ad instead of on the link that you wanted. And we worked really hard to make sure that that kind of behavior wouldn't ever happen. A lot of other React implementations, as different components on the page finish rendering, they'll sort of pop into place. It'll look sort of like popcorn as it comes on. Instead, what we do is we block the render of later components on the page until the earlier components are ready, and then release them onto the page only when the logical chunks are ready. So this makes it look like the entire page just snaps in all at once, really smoothly and really cleanly, and then sort of logically loads as it moves down the page below that. We also keep track of where the fold is so that the page becomes interactive once you've shown everything that will be visible on the screen, and then you can let trailing data come in from behind. And this really helps us address that impatient user that expects the data to be there in 2 seconds. They get just above the fold content, it loads snappily, they don't click on something they didn't expect, and then we can load the rest of it in the back of the page. It's also really fast. One of the things that React Server does is it allows you to pre-compute data bundles. When you have a route on the client and you know probably what the next action the user can take is, you can pre-request the set of data that you'll need for the server, and the server can go and fan out all of the requests and gather a data bundle, and then only release it to the client once the request is actually made, which really gives you a really incredible, fast, snappy, like, oh my goodness, they knew about what I was doing before I even did effect on the page. It also has a lot of things to help us be kind to our backend servers. And one of the things that can happen when you're first moving to a server-side rendered stack like this is, well, you don't want to wait 5 or 10 seconds while your long tail of requests comes in. So if your server's under load and it's struggling, your API server, you will start to release the code to the client faster, right? You hit that 2-second timeout, you release the what you have to the client, and then the client makes the exact same data request that your server did, which effectively doubles the amount of load on your API server. What we do instead is we don't make that second set of requests on the client. We continue to gather the data and leave the HTTP connection open between the server and the client, and then only release the data as it becomes available. So you have this sort of straggling effect of late arrivals. If we've done it right with the fold, then what will happen is you'll see the initial fold load as expected, and then the stuff that's below the page will sort of trickle in behind you, allowing you to have a much more rich page content as you move down the page. At the core of how this works is our page API. I've shown here just a really simple example of our routes. You can see at the top you have a routes.js. This routes file connects the page to the route slash. So we have here the .example, and then we have the example page. The pages are just classes with lifecycle methods, and and I'll go through some of those lifecycle methods here. The first one here we have is the get title and the get meta tags one. In particular, what we're doing here is we're just returning a new class that is a React Server page, and that the React server instance is going to instantiate that, and it's going to call get title first, so that it can release that title to the top of the browser, and we can have the title at the top of the tag. And then we have the get meta tags, right? We can start calculating the head element. So this is the kind of thing that happens, right? You write a bunch of different lifecycle methods that get called on it. The most important lifecycle methods are the get elements page and the handle route lifecycle method. The get elements, if you were only going to do one thing with your React server pages, it would be get elements. Get elements returns the body object of your document as React elements and is where all of the magic happens. Handle route is what gets called when the router is trying to resolve whether or not a route matches with one of the existing pages. So we use it a lot to check, for instance, if the query params point to a valid user or whatever else it is. This example here just extracts a single parameter out of the query params and then places it onto the page with the param. We also have lifecycle methods for style sheets and body classes. One of the things that we discovered fairly early on when we were working on this project is that it's really easy for a single developer to tank the performance that you've been working really hard to get by adding a single blocking JavaScript file to your application. You know, you've spent all this time getting everything right, getting the page loading just fine, and then one person adds one blocking JavaScript and you're busted. We maintain our own fork of loading and blocking JS by Yahoo, if I remember correctly, which allows us to asynchronously load non-blocking JavaScript, even if it were written in a blocking way. And we do the same thing with the head style sheets. They're not allowed to block the page. And this really sets us up very well for HTTP2, which means that we have a manifest of all of the JavaScript and all of the styles that will be available for us to deal with, and we can push those to the endpoint once HTTP2 becomes available. I know that Guillermo and James A. Snell are making great progress on that, and hopefully we can have that fairly soon. They're looking, I think, for a Node 8 release, and we're looking to get on that very quickly thereafter. The body classes here, because you don't produce your own body element, that's the way that we allow you to put classes onto your body. I talked a lot about how we partition the data to make it so that you can deal with data that's slow, and then you can deal with this buttery smooth page load. These root containers and root elements and the fold are the heart of that. And this is a fairly complicated example, and it's a little bit contrived, but I want to walk through this because I think it's really elucidatory for how this works. We have this root container which contains all of the elements that are going to go onto the page. And then you have the three separate portions of the page that we're going to load: the header, the main content, the SEO content, and the footer. The header and the footer usually are static content. They don't require a lot of complicated JavaScript, and they'll load immediately. And so what we'll do is you'll load them and release the header down the page. But then you'll block, even though the footer's done, because we're waiting for the main content and the SEO content to be released. So what we do is we hold on to the header, we hold on to the main content, we wait for them both to resolve, and then when we hit the fold element, we release both of them to the browser and we make them interactive. Then we wait until the SEO content data is resolved, and then we release it and the footer, which has now been rendered for quite some time, down to the page. So you get this really great loading where you get the header and the main content at once, and then the SEO content and the footer can trickle in later. And that avoids page jank. We also, then for client transitions, we export a link and a navigate to function. This is how you then, on the client, move between pages. The bundled data option here is the one that allows you to pre-compute data on the server beforehand. We also ship with request local storage. The request local storage is scoped to a single request object, and it always returns the same object wherever it's required. So you can use it as sort of just a bag of holding. You can just put sort of whatever it is that you want for a single request into that and not have to worry about passing the same argument through a long, complicated set of functions to get to the bottom of it. A good example of this is we attach our request IDs to this. So if you're logging from a helper that's far removed from the initial request middleware, you can still have access to that ID for logging purposes. And we also expose a fairly large part of the React Server API through the request context. So in this case, we have the server stash and the response object that's available through our request local storage object. We also expose an agent. The agent allows you to make requests to and from the server and is wrapped in a cache. If you've ever used Super Agent, it's just a wrapper around Super Agent that just makes it easier for us to deal with how to put plugins on it and how to manage the cache and the data that's available from it. And we also have our Navigator. The Navigator allows you to tap into the client-side transition lifecycle. The methods are all called in this order. We emit them as events, and you can listen for them and say, for instance, when you want to start the navigation to a new page, if you want to unregister a set of listeners to other event emitters, then this is a great time to do it. One of the things that we've really focused on a lot is a great developer experience. We really strongly believe that the root of a good customer experience is a great developer experience. If your developers don't want to ship good product, your clients aren't going to have good product. And so we have spent a lot of time making sure that the onboarding process is really simple, that generating a new project is really simple, that you have code splitting out of the box. We have module tagging, which will take your logger calls and will replace the token with we'll replace a token with the name of the file in the directory, so that when you're logging on the client side, you can know where the log lines are coming from, what lines and what files they're coming out of. And we ship with hot loading by default. So if you come in and you say React Server start -- hot, you get hot reloading. And we really believe that this developer experience is one of the best that's out there on the market right now. So what's coming up next for us? Right now, we're working really hard on getting Webpack on the server. One of the things we would really like to do is get hot module reloading working so that you don't have to take down the server when you ship server-side changes. We also have been working on clustering. Right now, you can use PM2 to do that sort of clustering, which spins up the clustering for you and works just fine. But we would much rather have the support for our module tagger work for IPC so that we can have tagged IPC between the two of them. We'd also like to work on multi-site support. Lots of companies are running what are logically different sites, but developers want to develop on them in a single way. So we'd like to be able to bring up many sites in a single cluster together. And then, of course, we are anxiously awaiting the shipping of HTTP2 so that we can start pushing our scripts and our style sheets to our customers. So I'd really like to encourage you to come and try React Server. You can just focus on writing components and managing state, and we can just handle the rest for you. These are the steps that you can take to get started. We ship with a CLI, run init, run add page, and run start, and you're up and running. So any questions?
Doug, can you hear me?
Yeah.
Okay, we're gonna put your face up here, so don't be picking your nose or anything.
I won't be picking my nose, I promise.
All right, great. All right, so if anybody has questions, you can come up to this microphone up here and line up. Any questions?
Ooh, if you're talking, I can't hear you.
You hear us now?
Yeah.
All right.
All right. So I actually had, where's the camera over here? So I did have one question that when you were talking about the ad space where they, they're loaded right before and then people click on them, that is, infuriating to a lot of my users. And I'm wondering, is there a way to also be able to not allow them to put the X so small that you're always going to go to the Google App Store or something else when they're not trying to, they're trying to close it. So how can we take over what they're trying to do? I know that it's good for us that they go to the App Store. We make money off of it, but it pisses our users off. So how do we stop that?
what I hear you asking me is, I have this problem with ads. When I load up an ad, the X in the upper right-hand corner to close the ad is really small compared to the size of my thumb. I can't figure out what it is to be done about that. And how do I solve that? Is that your question?
Yeah, that's the question. And then also, is there a way to close that ad outside of, what they're trying to take over? They want you to go to their.
So as to the
I
problem,
get so much feedback about that I need to figure out how to deal with that.
yeah, the problem with the X is a pretty pernicious one. In particular, there is a whole class of these ads where the X actually doesn't do anything the first time you click it. They actually check for the first click that happens on any part of the button, and then they enable the X for the second load. And so that X doesn't actually even do anything, even if you somehow did manage to click it properly. Unfortunately, JavaScript is the kind of world that we live in where nothing is sacred, and once you let somebody load JavaScript on the page, there's nothing that you can do to stop them from doing those kinds of terrible things, other than to say that this is an ad provider that will no longer support. So there's nothing that we can do at the framework level that I'm aware of that would prevent that kind of behavior, unfortunately. I agree with you, though, that it's really just a terrible experience and that I hate everything about it.
Are there any other questions?
Hello. So at the very beginning, you said that this was a battery included or battery powered framework. So what the heck does that mean, and what specifically were you referring to?
Yeah, when we say batteries included, a lot of times when you encounter a new framework on the web, and I would say this about React in particular, as provided, it solves the problem of I would like to write a function that takes state and produces UI. But how you get it onto the page is sort of unclear. Like, there's a lot of inherited wisdom about how to set up a bundler and how to do your compilation and how to deal with JSX that isn't included in the library because it's not part of what they do. It's not part of what's important to them. It's not part of what, I shouldn't say important to them. It's not part of the problem that they're setting out to solve. And what we're trying to say is, by saying batteries included, is when you start out, it should do everything. It should work. You shouldn't have to learn a lot of new concepts to make it happen. We're not trying to solve the scope of our problem is very large, which is to say we want you to fire up a new React server instance and it to work out of the box without having to make a lot of changes. So the CLI that we provide sort of papers over a lot of the things that you might have to do. In particular, we generate an express server for you. Like, we do a lot of code generation that produces a server that then runs, which you wouldn't do in a lot of other Vue library frameworks. Does that make sense? Yes? No? Does that answer your question?
Thank you.
Yeah, she said yes. Anybody else? All right, I got one question, Doug, and it's that, do you have any real-world performance stuff you can share with us? What happened when you deployed this to production? Did you see improvements anywhere?
I do have real-world performance numbers. I don't have them up in front of me right now. I do know the thing that I remember most about when we first turned it on was the change in developer happiness. We had a lot of developers who were complaining about how hard it was to work in our existing system and how hard it was for them to ship code, and that the changes for us that we really championed with React Server was the change in our annual developer survey. We had a lot of developers saying that they were much happier with the new information. I can share the blog post with you afterwards if you have some sort of manifest that you send out afterwards that has the actual performance numbers behind it.
That's one of the biggest things that's really great. I mean, but do you have also any qualitative improvements that you saw? Like, what users might have noticed, or even if you were to speculate?
Yeah, what users might have noticed is the page loads. We were having a problem for our. I was working at Redfin at the time, and we were struggling with home pictures that would pop in afterwards, right? So you would see, some of the home facts would load, and you'd be sort of reading them, and then they jump down the page, and then a carousel of images would pop up above them, and we solved that problem. We got a much better page load that was much smoother, much easier for them to deal with. That was a big improvement.
Okay, thanks. Does anybody else have more questions for Doug? Oh, we got one more up here. Doesn't tighten? All right.
Hey, Doug. First of all, thank you so much for such a tight and solid presentation. Can you hear me okay?
Yep.
No, I'm too close. All right. I wanted to ask, the website seems to indicate that Yeoman is the preferred way to kind of get started and up and running with React Server. How does Yeoman and the CLI really relate to each other? Is the CLI replacing Yeoman, or is it built on top of it?
The CLI is replacing Yeoman. I've used Yeoman for a long time. I've been a part of the Yeoman community for a long time, and we've had a lot of trouble with the Yeoman environment. There's been a problem for us with the way that they process their generators. We keep our generator inside of a mono repo that's managed by Lerna, and the Yeoman bot can't parse that and can't figure out how our generator is generated. And we've had some other frustrations with managing it. And we've decided that since we want users to be using the CLI for managing their application state anyway, that it would be better to just have a single application that handles both the initial onboarding and then also the long-term thing. And so we're slowly moving away from the generator and moving to using exclusively our own CLI.
Is the CLI built on top of any of the more recent CLI frameworks, or is it sort of an independent scratch build?
We use Minimist for our args parsing, but we're not really built on any framework. It's sort of we hand-rolled our own. It's loosely based on sort of the same architecture stuff that we found from other CLI applications out in the wild, like Lerna, which I also contribute to, but it's not like it's built on top of any actual CLI framework or anything.
Got it. Thank you.
No problem.
Anyone else? Okay, Doug. Thank you so much. It was a great presentation.
Thank you.
I don't know if you could hear that, but that was applause. And you're welcome to stick around and watch the rest. But we really appreciate you taking the time to talk to us. Thanks a lot.
Anytime. Thank you.